Chapter 2, Section 3, Dot product and vector norm. In this section, you will learn what dot product is and its geometric meaning, what the vector norm is and its geometric meaning, and practical meaning of dot product and vector norm. The dot product is an operation that takes two vectors and returns a single number. The dot product measures how much two vectors point in the same direction. Also, it is useful for calculating angles and determining orthogonality, that is, whether two vectors are perpendicular. Given two vectors, u and v in n-dimensional space, the dot product, denoted as u dot v, is calculated in this way. Let's see a concrete example. Consider two two-dimensional vectors, u and v. Using the formula, the dot product of u and v can be computed in this way. The dot product has a geometric interpretation that relates to the angle between two vectors. The formula of dot product can also be expressed in this way. Here, u enclosed in double vertical bars is the magnitude of vector u, and v enclosed in double vertical bars is the magnitude of vector v, and theta is the angle between u and v. If the dot product of u and v equals 0, it means that these vectors are orthogonal to each other. It is because cosine theta equals 0 when theta is 90 degrees. The dot product is widely used in data science. First, we can use dot product to quantify similarity between two vectors. For example, in text analysis, vectors can represent documents, and we can use the dot product to determine how similar two documents are. Second, we can use the dot product in projecting one vector onto another, which is essential in reducing dimensions in datasets, such as in principal component analysis. Third, we can use the dot product to quickly check if two vectors are perpendicular. It is useful in understanding feature relationship and data independence. A vector norm is a measure of the length or size of a vector. It gives us a sense of the magnitude of the vector. The vector norm and the vector magnitude are closely related, but not the same. While the magnitude of a vector refers to its length or size in Euclidean space, vector norm is a more general concept and can be defined in various ways. There are several types of norms, but we will focus on the most common types, the Euclidean norm and the Manhattan norm. They are also called L2 norm and L1 norm, respectively. The Euclidean norm is the most commonly used norm, representing the straight line distance between the origin and the point represented by the vector in space. For this vector v, the Euclidean norm denoted and calculated in this way. It is the 2 norm of v, also called the Euclidean norm of v. Let me show you an example of Euclidean norm. Consider this three-dimensional vector v. The Euclidean norm of v can be computed in this way. The Manhattan norm, also known as the L1 norm or taxicab norm, represents the sum of the absolute values of a vector's components. It measures the distance between points in a grid-based path. For this vector, the Manhattan norm, the one norm of V, is calculated in this way. Consider the same two-dimensional vector. The Manhattan norm of V is computed in this way. As you can see, it measures the distance between points in a grid-based path. Vector norms are vital in various machine learning and data science applications. For example, the concept has been applied to normalization, regularization, and distance measurement. The first is normalization. We can use vector norms to normalize data. That is, we can transform features to have consistent scale. This operation is important for algorithms like gradient descent. The second is regularization. When developing machine learning models, we can use vector norms for regularization techniques such as L1 and L2 regularization. These techniques help prevent overfitting by encouraging sparsity in the model coefficients to simplify the model. The third is distance measurement. We can use vector norms to measure distances between points in space. Distance measurement is crucial for clustering algorithms, nearest neighbor searches, and other data analysis tasks. The dot products and the vector norms are fundamental concepts of linear algebra that are very important in data science and machine learning. The dot product expresses how two vectors are related to each other. The vector norms represent the length of a vector and are applicable for various purposes, such as normalization, regularization, and distance measurement. Knowledge of these concepts and operations is significant to understanding various concepts and operations in data science. Thank you for watching. Please thumbs up and subscribe to my channel.